In February 2001, two men climbed a barren rock in the middle of the ocean and found 3 strange insects. They should not have existed. 80 years earlier, rats had nearly wiped out the entire species. Then scientists noticed something extraordinary. All 3 insects were female. It seemed there was no hope left, but this species can reproduce without males. To give it a second chance, people first had to declare war on 300,000 rats on a neighboring island. To understand how these 3 became the last of their kind on Earth, we have to go back 80 years to the ship that started it all. Lord Howe Island, 1,455 hectares of volcanic land, 600 kilometers off the Australian coast. A UNESCO World Heritage Site, the world's southernmost coral reef, 400 residents, and once an animal locals simply called the land lobster, Dryococelus australis, a stick insect up to 15 centimeters long, weighing up to 25 grams, the heaviest wingless stick insect ever to have existed. It lived in tree hollows, came out at night, formed pairs. Fishermen skewered it onto hooks as bait, so ordinary was this creature. For millions of years, this island had no terrestrial predators. There was nothing to hide from. Then a ship arrived. In June 1918, the steamship SS Macombo ran aground near the northern tip of the island. The vessel was stuck for only a few days, and that was enough. While the crew worked to free it, black rats came ashore. Rattus rattus, the classic ship stowaways that flee holds for dry land. For the rats, it was a paradise without rules. Mice already lived on the island, but small and inconspicuous. The rat was a different force entirely. On land with no snakes, no predatory mammals, no natural enemy of any kind, its population exploded. It ate everything: seeds, shoots, bird eggs, chicks directly in their nests, insects. It entered houses, gnawed electrical wiring, stripped vegetable gardens. What was catastrophe for the island was simply an unguarded table for the rat. And the first to vanish from that table were those who could not run. The land lobster was wingless, nocturnal, and slow, the ideal prey. Within 2 years, the rats had eaten it into oblivion. By 1930, no living individual could be found. The species was declared extinct. And not only the species. Along with the stick insect, the island lost at least 5 bird species, 2 plants, and 13 invertebrate species, with around 70 more pushed toward the brink. An entire branch of life, erased by animals that had simply walked off a ship. Here is the paradox. The greatest threat the island ever faced came not from storm or from human hands, but from a few uninvited passengers in a hold. And to correct that mistake a century later, people would have to do something almost as extreme as the catastrophe itself. First, the rock. Ball's Pyramid does not look like a refuge. It is a fragment of an extinct volcano, a narrow blade of stone jutting 562 meters out of the ocean. Climbing it is prohibited to everyone except scientific expeditions. In 2001, a team of 5 went up anyway. National Park Service scientists David Priddle and Nicholas Carlisle, 2 entomologists, and local ranger Dean Hiscox, an experienced climber who could guide the others through the crags. They climbed 120 meters up the slope. They found only crickets. Ball's Pyramid has no forest, no tree hollows. "There's not a single branch here thicker than my arm," Carlisle would say afterward. A plant capable of sustaining such an insect seemed impossible here. And then, already on the way back down, they saw it. Beneath a single tea tree growing from a crack roughly 100 meters above the water, there was large frass. Only a large invertebrate could have left it. And the team understood the key thing. In daylight, you will find nothing here. This animal comes out at night. So Carlisle and Hiscox returned after sunset with a camera and headlamps. Beneath that same bush, they found 3, 2 adults and 1 nymph. All female, feeding on leaves of the endemic tea tree Melaleuca hawaiiana. Beneath the bush, moisture seeping through the rock had built up a cool, damp cushion of plant debris. pockets of shade where the insects could shelter from the daytime heat. Later counts would reveal the entire wild population to be around 24 individuals. The entire range, approximately 300 square meters. A patch on a vertical cliff face smaller than a basketball court. These insects had held on here for 80 years. No one knows how their ancestors crossed 23 kilometers of open ocean in the first place. Perhaps on the feet of a bird, perhaps with fishermen. No one knows how they survived on a single bush while their kind was wiped out on the home island within 2 years. But now they had been found in time, because the situation was desperate. One rockfall, one drought, one surge of invasive weed, and 300 square meters would become zero. The scientists reached a conclusion that would define the next 20 years. These animals had to be removed, at least some of them, before the cliff changed its mind. The Australian government hesitated for 2 years. No one knew whether or how to disturb such a fragile population. There were meetings, studies, and finally permission to take 4 individuals. When the team returned for them, a rockfall occurred on the cliff. At first, they feared the entire population had been lost, but the insects survived. In 2003, 2 pairs were taken. One went to a private breeder in Sydney, Stephen Fellenberg, the same person who had climbed the rock in 2001. The second pair went to Melbourne Zoo. The Sydney story nearly ended immediately. Within the first 2 weeks, the female laid 21 eggs, and then, on the 29th day, the male died. The following day, she died too. The pair on whom half the hope had rested was gone within a day, but 8 nymphs hatched from those eggs. A thin thread, but a thread. In Melbourne, the main drama was unfolding. The pair there was named Adam and Eve. The name was not arbitrary. These insects behave in a way almost unique among their kind. They form pairs. The male follows the female, and his behavior depends on hers. At night, they sleep together, the male wrapping 3 legs around the female as if sheltering her with his body. Another oddity, offspring hatch looking nothing like their parents. Nymphs are bright green and active by day, darkening to black as they mature and shifting to a nocturnal existence. Adam and Eve were not simply specimen 1 and specimen 2. They were a pair in the most literal sense. The person responsible for them was Patrick Honan, head of invertebrates. Almost nothing was known about how to keep these insects alive. Everything had to be worked out by trial. At first, things went well. Eve was laying small, pea-sized eggs. Then she fell ill. Honan worked every night for a month trying to save her. Nothing helped. Eve weakened, curled up, and lay in his palm, by his own account, almost dead. And then, on pure instinct, he mixed a solution of calcium and nectar. He began dropping it into her mouth, 1 drop at a time, while she lay coiled in his hand. She revived within hours. She rose and began to walk. And here the species' second wonder came into play, the same one that had made those 3 females on the cliff matter at all. Stick insects can reproduce without males. A female lays viable eggs on her own, and from those eggs hatch only females, exact copies of their mother. This is parthenogenesis, and it is almost certainly what kept the species alive through all those decades when individuals numbered in the single figures. The eggs themselves are easy to overlook. Each one the size of a tic-tac, cream white when fresh, darkening toward black as it absorbs moisture. The female lays them in batches of 9 or 10, with a week's pause between clutches, and buries them in the soil. Then silence. Development takes months. The embryo waits up to 9 months inside before hatching, and when it finally emerges, a small miracle of scale occurs. The nymph is 3 times larger than the egg it just left. It was folded inside like an origami figure, which meant every clutch Eve laid was not just a number in a log. It was months of waiting over a container in which nothing appeared to be happening. Of Eve's eggs, only the first 30 proved to be fertilized, but it was enough. The entire enormous captive population that would follow traces back, in essence, to one female lifted from a cliff. While zoos were counting eggs, the insect's home remained occupied. By early 2019 estimates, Lord Howe Island held more than 300,000 rats and mice. Returning the stick insect there meant releasing it directly into their jaws. So the island decided to do something no one had done on an inhabited landmass of this scale: eliminate every last one. The weapon was brodifacoum, an anticoagulant, and its power lies precisely in the fact that it does not kill immediately. The poison blocks an enzyme in the liver that recycles vitamin K. Without it, blood cannot clot. For 2 to 3 days, a rat feels normal and returns for more bait, while inside it, blood is already seeping into its tissues. It dies of internal hemorrhage several days after eating. This delay is deliberate. If a bait pellet killed instantly, survivors would connect the deaths with the food and stop eating. This way they eat until the end and feed it to their young. In 2019, after 20 years of preparation, pellets were dropped by helicopter over the protected area and laid by hand in the settlement. Detection dogs and cameras followed in their wake. Before the operation began, Taronga Zoo removed live birds from the island to protect species at risk of secondary poisoning, those that might consume a poisoned rodent. Around 200 woodhens and 125 currawongs. They were kept in captivity until the campaign concluded. By October 2019, the operation had eliminated approximately 150,000 rats and 210,000 mice. Mice were not recorded on the island at all after July of that year. By protocol, an island is declared rodent-free only after 2 years to allow any survivors time to breed to detectable levels. For 18 months, everything looked perfect. Then, in April 2021, just months from the end of the countdown, a resident saw a rat run across a road near the cemetery. 2 were caught, a male and a pregnant female. 1 litter and everything could have started again. The response was immediate: ground baiting, dogs, cameras. Over 5 months, approximately 96 rats were removed, 44 adults and 52 juveniles. DNA showed all of them descended from just 2 individuals that had survived the first campaign. 2 rats against an operation targeting 300,000. That was almost enough to undo everything. The 2-year clock was reset and restarted from 0. The second countdown reached its end in mid-2023. In July, teams arrived on the island with dogs, and for 2 weeks they systematically swept everything, both the settlement and the protected zone. More than 950 device checks, 140 tracking tunnels, 32 cameras, 300 wax tags and bait cards. No sign of rat, no sign of mouse. The results were verified by independent experts from New Zealand's Island Eradication Advisory Group. The conclusion was official: no rodents on the island. Lord Howe had become the largest inhabited island in the world from which rodents had been eradicated, and the island began to respond. The endemic woodin, of which fewer than 250 individuals remained before the campaign, had grown to more than 1,600 by March 2025. Beetles, weevils, wood cockroaches, all those invertebrates that rats had been eating for decades began multiplying again the moment the predator was gone. Then the island returned something no one had asked for. In 2022, 2 scientists surveying a control site on Lord Howe itself found a living endemic wood cockroach, Panesthea lata, a species considered extinct on the main island for more than 80 years after the rodent invasion. It had survived an entire century of rats by hiding, quite literally, under rocks. It turned out the stick insect on the cliff was not the only species that had managed to wait out the catastrophe. It was simply the one found first. As for the insect itself, by that point it had documentation of its identity. In 2017, a team led by Alexander Mikheyev compared the DNA of cliff specimens against museum samples collected on Lord Howe before the extinction. The divergence, less than 1%. The same study uncovered another surprise. The genome of this insect turned out to be enormous, more than 4 billion base pairs, larger than the human genome, and most likely hexaploid. Instead of 2 copies of each chromosome, the stick insect carries 6. The animal that was nearly erased by a handful of rats holds one of the largest known genomic libraries among insects. This is genuinely the same species, the scientists concluded. The animal from the cliff and the animal from the old island are one and the same. The physical differences prove to be within the species' natural variation, Museum specimens were lighter in color and more robust, cliff specimens darker and more slender, variations within a single species under different conditions. In captivity, meanwhile, the count was no longer in dozens but in thousands. In 2008, Jane Goodall visited Melbourne Zoo. Honan showed her the rows of incubators. At that point, they held 11,376 eggs and around 700 adult insects. A species that 7 years earlier had fit beneath a single bush was now being counted in incubated eggs. Later, eggs from Melbourne were sent to zoos in Bristol, Toronto, and San Diego, and an insect that had nearly vanished began living on 3 continents. And yet this story cannot be called finished, because the wild population of the stick insect is still where it has always been. On Ball's Pyramid, estimates range from 9 to 35 adults on the same patch of cliff, 23 kilometers from the island that was cleared for their sake. Reintroduction is being prepared, but as of today, not a single land lobster has returned to the wild on Lord Howe. The island is clean. The animals are not yet ready to go home. There is a deeper fault line. Almost the entire captive population descends from one female. Thousands of insects from one set of genes. For the species, this is a genetic bottleneck. When all descendants are family, any disease or weakness passes to all of them equally. Saving numbers is not the same as saving diversity. And the last, quietest problem. The entire catastrophe began with one ship in 1918. The entire second crisis of 2021 began with 2 rats that survived an operation targeting 300,000. A cargo vessel still comes to the island every 2 weeks. Planes land every day. Yachts call in. One pregnant female in a hold is enough. One time. And 100 years of work could be reset, just as the 2-year countdown was reset in the spring of 2021. The island won this war, but it cannot stop fighting it. The work continues, now in laboratories and enclosures. A species that once fit beneath a single bush lives in thousands across 4 colonies on 3 continents. There is more than enough material for a return, but the final barrier is the insects themselves. Decades in captivity may have given them bacteria that never existed on Ball's Pyramid. You cannot simply breed them and let them go. Trial enclosures are being built on Lord Howe. Every step is weighed carefully. No date has been set, but for the first time in 100 years, one is possible.